you've all already noted, I'm Martin. Some of you may know I've joined the team, Lazarus team, in 2008, and that was just for a single fix in the debugger back then. And yeah, what happened since is a lot. I'm still fixing things, and somehow I ended up here doing this talk. Now, I don't know how familiar everyone is with the debugger we asked earlier, and everyone is currently on the 2.2 branch 7. Anyone who already uses the trunk, the current main Lazarus? Okay, so then some of the stuff I'm going to present are actually news to you because they haven't yet been released. So what we're going to look in this presentation is how it started, what we already got, what we will have with the next release, and some of the ideas we have for the future. Obviously, ideas for the future are constantly changing, so that's open. It's a history. FPDebug is actually pretty old already. It's been around since 2006. Was started by Mark back then. It's been named FPDebug since 2 years after that. I've been working on it since 2012, and we talked about years earlier when we mentioned the DAB debugger. So he did some work on FPDebug starting in 2014. DAB, that's a communication protocol between an IDE and a debugger. There was communication between some of us earlier about how to, or whether there is or would be a debugger for debugging Pass2JS directly from the IDE, which there currently isn't, and I don't know if there's anyone in plan. Yoast has worked on debuggers that can be outside the IDE, but I don't really know how far he is with that, so I can't answer on those questions. And that's called DAB, so basically that's the protocol that the IDE uses to talk to the debugger. I know Yoast has done that, so you can use FPDebug when you use Visual Studio. So Visual Studio can actually invoke FPDebug, give you Pascal-related debugging within Visual Studio. But that's not for the presentation. I just mentioned that because it came up a little bit earlier today.
Who's yours?
I might have mispronounced that, Michael. What? Yeah. So I think he's on the FBC team, isn't he? Yeah. Okay. So I only know him by email, so I can't really comment much more on that. But he's done a good job on parts of FPDebug, so credits to him. In 2015 was the first time when we actually released an IDE that had some usable parts of FPDebug contained in it. That was done mixed with GDB because of FPDebug didn't have all the functionality, so we substituted the missing functionality by using GDB and then having FPDebug on top of it to do the rest. This came in handy later because a couple of years later, Apple decided to scratch GDB. We were left empty-handed. And that's when we reused the concept. That's still in use today for anyone who is using Apple. They're using a mixer of LLDB and FPDebug. So basically, LLDB is code signed by Apple, so it can be used as a debugger without having any trouble that you'll have to go and code sign yourself and deactivate security measures and all of that stuff. And FPDebug, on the other hand, knows what Pascal is, how a Pascal expression like you would enter in a watch field like a comparison or any operation, any pointed dereference or something. How that works, an FP-debug knows that much better than LLDB. So you get better results this way. Last year, we had the first release which actually had a pure FP-debug in it. And this year, somewhere soon, I hope, we shall have 2.4, which officially makes FP-debug the default debugger for Windows and Linux. So everyone who hasn't done yet will get a once-off prompt if they want to change. And if they want to, the IDE will adapt the settings accordingly. And then you'll be using FP-debug if you don't do that yet. I've mentioned 3 people on the last page, Mark, Joost, and me working on FP-debug. Obviously, a lot more people have worked on it and done a great job, but it would have cost a lot of time to find out all the names from the Git history. So I just mentioned them as there were more people, but I don't have all the names. And 2 other projects that were attempted during that time, just to quickly mention. The Lazarus team, people from last part, weren't the only ones who tried to improve the debugging experience. Kraim, whom many might know, probably have heard from. He does FP guy. He did try a version of FP-debug, and then Dimitri tried something called Doobie, which I believe shared some code, so it was pretty similar. I don't know if those projects have halted. The dates I found were the last changes on the project sites. If the authors go back to that, I don't know. So that's that. So what do we have now? First of all, we have a lot of different debugger backends. As I've mentioned before, we have various hybrids. So to start with, GDB, everybody knows that we've been having that for a long time, and we've been having problems as long as we had it. It's still maintained. We still need it for remote debugging with things like GDB server, or people who, for example, use FreeBSD or embedded targets. They still will use GDB and GDB server. We still have the hybrid GDB with FP-debug, even so today that's not of that much interest anymore because we have a fully functional FP-debug. For the Mac, we have the hybrid there. There is an FP-debug based debugger for AVR. That's not mentioned. That's not actually done by the Lazarus team. That's by a contributor outside the team, but it's still definitely worth a mention. It's a very good product. And there is, as I've mentioned, the DAB version that we have there. Okay, before I continue, any questions arise while I go through the different slides, and I'll also have some examples which we're going to go through in the IDE later on. Then don't keep those questions to yourself, bring them forward. So what we had for a long time are pretty good breakpoints with a lot of functionality, which not everybody might actually have experienced all those functions. That's why I've mentioned them here. You've got conditional breakpoints, and that's one of the things that has also improved with FP-debug, because now the conditions will actually have a much better Pascal support. So in the past, when you put a condition on a breakpoint, GDB had to understand that expression. So it had to be within the limited range of Pascal that GDB did understand. and that was quite limited. Now with fpdebug, you can put almost anything that the Pascal compiler would accept into the expression, and it will be evaluated. You've got hit count based breakpoint, so you can simply count how often a point in your code is reached or stop it after a certain amount of times. You have breakpoints that don't actually need to stop the application, which is very valuable if you, for example, debug something that's focus related. Because if you have a function that changes its behavior when the focus changes of the application, and you stop the application and shift focus to the IDE, then you might never get to the behavior that you try to debug. So basically, you can just see that the breakpoint hits. You can actually look at your watches, at your locals. You can record them and continue the execution without ever shifting the focus, which means, for example, if you have a pop-up menu where you want to debug something in there, and if the focus would change, if the application gets deactivated, then the pop-up menu would close and you would never be able to debug it. That's a feature we already had, but that probably not everybody using the IDE knows. That's why I'm bringing them up before I'm going to the new features. So yeah, as I said, you have the option within the breakpoints to just log stuff like a message, I've reached this line, to evaluate something, get the value of a variable or of an expression, and also to take a complete snapshot of everything you've got in the watches window. So you can have all the watches for which you want to have values in your watches windows. All that gets recorded, and you can have a look at it at a later point in time. And also a feature that I think is not used very often, but can be very useful. You can have breakpoints that depend on another breakpoint having been reached before. So that means if you have a point in your application where you might want to stop, but only when it's called by a certain caller and not otherwise, and it's otherwise called very often, then you can have that breakpoint disabled and enable it only when you come there through that specific caller path. Now, those are features we already had, but if that's of interest, I can just show it in the IDE. Okay, so then I'm just going to, okay, the problem is, there we are. No, that's not my program. New project. Program. Well, this part wasn't prepared. We have the I've prepared. One moment. So right. One. One. Okay. So basically what I want to do now is I want to stop on the upper right hand, but only when it's called from the second invocation of foo. So I'm putting a disabled breakpoint here. I'm going to its properties and I'm putting it into a group. Simple A will be okay for this. And I'm going to this breakpoint here. And I'm going to the properties. And I'm going to say in this breakpoint, I want to enable the group A. So then what will happen is it will call foo the first time, but the breakpoint above is disabled. It will be passed, it won't stop. It will reach that breakpoint here, and I'm also disabling that this breakpoint stops. So I don't need to continue here, it will automatically continue. It will enable that breakpoint, and then we should stop here on the second call. And we will be able to see in the stack trace that we've been called from the second time now. And if my program would continue, I could add another breakpoint further down, in which I would then say disable the group A again, so that the breakpoint becomes disabled again and wouldn't stop any further calls. So let's start that. Is that done with debug? That could be enable draft. And that was wrong of me. I did start it without debugger. Somehow the which window goes on top doesn't go the way I expected. And we stopped there. And if we go to the call stack and look where we were called, line 11, that's the second invocation. So when we called foo the first time, we went straight through the breakpoint. We then went to line 11, which is down here, called it again and stopped. So basically now if you have an event handler that's called from lots of various locations and you're only interested in one location that calls it, then you just set 2 breakpoints in that location that calls it. The first one to enable that breakpoint, then have the code that calls the event, and then when the event returns, have a second breakpoint that disables it. And the 2 breakpoints that enable and disable the other breakpoint, they simply don't have the break property set, so they just run straight through. And yeah. Yes, you can enable multiple groups. There is a dash button here where you can add them, and I believe it's basically comma separated. I would have to check that, but basically you go here. If I only have that one group because I only have one breakpoint which is in group A. If I had a breakpoint in group B, then I had a second line here with a checkbox and could check that. And also if you go to the breakpoint window, you will see the actions here, and but scroll over, you'll also see which breakpoint is in a group and in which group it is. Yeah. And because I mentioned it before, well, we didn't have watches, so we wouldn't have any watches here, but we do have new debug windows. So basically, what I mentioned before, that you can make records of the watch window and the locals window and the stack trace, and don't have to stop to make that record. So if you are debugging something that's focus related. Now, I didn't have any watches, so there isn't anything to be seen in the watch window now, but this history window basically then has a list of all the breakpoints at which you stopped, or at which you went through. And basically for that, in the breakpoint properties, you would say take a snapshot and then you get that snapshot. And then once you've collected like 20, 30 snapshots, you can go here to the history window and you can select them by double clicking them, and the watch window and the stack window, they will all be updated then. At the moment it's just a stack window and it's just by one line because I just stepped over one line to make a single entry here. So those are existing features. Any questions? That's fine. Good. So then we have watch points. So basically you can stop when specific data changes. That feature depends on the CPU. So on your average Intel computer, you can monitor up to 4 variables that can be up to pointer size. So basically integers, int 64 ints on a 64-bit machine. You can't have a full record like with many fields in it, because basically the CPU only supports to monitor for up to 8 bytes and only for up to 4 groups of 8 bytes. And anything above that, the debugger would have to stop after every expression and check, and that would really be very slow. Okay. So obviously we have all forms of single stepping. We've got the ability to pause at exceptions, to exclude exceptions from being paused at. Probably features that anyone who's used the debugger has encountered before. We've got the stack window, which I'll mention again later because it got some new features. The stack window, watches and locals that we have seen. The inspect and evaluate windows also had some updates, so we'll return to them later. This page is basically just for completeness for the thing. On Linux, we have a console window, because on Linux and on Windows, if you have a console application, Windows will open that black console windows and you'll have it and you'll see your output in it. On Linux, you need to have an existing console terminal of some kind. And the way terminal works in modern Linux is multi-process. So basically you have a terminal server in which the process is going to be run, and the debugger basically can't start your application in that terminal server. So you don't get a terminal, which is why the IDE provides a terminal window, which well, I can't show that here. It's a Windows computer, so it doesn't have that particular feature. And well, I've just mentioned the history window already. So that's the current state. Any questions? Too fast, too slow? Too boring, too interesting? Yeah?
Can you say something more? Since a month I use Windows 11, and I keep there's keeping coming question which WAF thing.
Yeah, but actually not a Windows 11 feature. That's on all Windows on Linux versions. So basically, TWAF, there are TWAF and stubs. And both of them are formats in which the debug info is written by the FPC compiler. So the way debugging works is the compiler on the one hand writes the machine code that the CPU is going to execute, and then in the same file it leaves notes for the debugger that says, well, you know, that variable is going to be at this address and it's going to be of this type. So if the user wants to see foobar, then just check this address, and it's an integer. And this can be done in stubs, which is a very old format and discontinued, and FPC. There may be still some platforms on which it's supported, but most of the main platforms don't actually. It's actually not supported anymore by FPC. Just need a minute to finish that. But basically, the default for FPC is to say that when you compile with debug info, is to tell FPC compile with whatever you think is best. Which means the IDE doesn't currently have a list which version of FPC thinks on which OS, which format is best. Which wasn't a problem because GDB knows both formats, but FPDebug only knows TWARF. So now we need to make sure that your application has TWARF on it. And because the IDE doesn't know when you use the default flag for FPC, it asks you which specific flag it should use. Now, if you only use FPDebug and you don't plan to switch between FPDebug and GDB or any other debugger, then you use TWARF3. It gives you the best results. For starters, it means your watches and your locals will have the upper lower casing that you had given them in your code. If you use TWARF2, all your locals are all uppercase. It also is better for certain data types. It can find more information. It can display more correct information, basically. So that's why the question comes up, and that's which value to choose. If you, for some reason, because you may do cross debugging in between or something, they have to occasionally use GDB, you might want to consider using TWARF2, because basically GDB doesn't like the TWARF3 info as produced by FPC. Some values are described in a way that just crashes GDB. So using TWARF3 and GDB just makes it more likely that your debug session doesn't lead to where you want it to go. Unless you want to debug the debugger, then that's perfectly fine. So that's where that windows come from. And one of the news for the upcoming 2.4 is that because one occasion where that dialog currently comes up is if you have a build and a release mode, a release and a debug mode in your build modes, that's where build came from, then when you compile in your release mode, you compile without debug info. But the current IDE still tries to start this executable in the debugger. And therefore, it will then ask you which debug format you want, which obviously doesn't make much sense because you just went to release mode. You didn't want debug format or debug functionality. So that's changed in the upcoming 2.4. In the upcoming 2.4, when you go to release mode, however, you need to recreate this mode. If you have an old project that's already created, it doesn't apply. But if you have a new project, you created a release mode, it will run it without the debugger. So in release mode, that question won't come up and run in the debugger, which should be what should be expected for the average case, I think. Question answer? You had something?
Yeah, I wanted to remind you that the article you wrote.
The what?
The article you wrote was about the 1.1, 2, and 3.
Yeah, it has a the Actual Place magazine has an article which is the first of a series on the debugger, which starts at the very basic. So this really only covers stuff we already have. And it does mention the dwarf settings, obviously, because when you first time use the debugger, you'll encounter that question. You need to answer it. And there'll probably be more detail on it as there'll be more of those articles we've written. So that's this. So then we get to what we have in 2.4. And I'll first go quickly through what is basically a copy of the release notes. And then I'll have a few examples that we'll open in the IDE where I'll show some of those features. Yeah. So we've got function calling, which I do list as a new feature in 2.4, even though to a tiny extent it already exists in 2.2, but it's rather unstable when you do it in 2.2. So in 2.4, you should expect it to work. Obviously, if you call a function in your debug application, you will get side effects if your function has any side effects. But yeah, you can call that a feature, you can call that an unexpected feature. That really depends on what you want to do. So basically, if you have a form or a button on a form and that button is hidden and you want to see what handle it has, then you might actually trigger the creation of the handle of that button, which in consequence might change how the application runs after this point. So when you call a function in your program, it's up to you to make sure that doesn't have any side effects that you don't want to have. On the other hand, you might want to do that for a side effect because you realize you are close to the bug you are trying to find, but somehow the side effect of that function hasn't yet happened. So you can just trigger it and don't need to restart your debug session. So it can be a positive thing, it can be a negative thing. It's just something one has to know when you use it. We have something called intrinsic functions. So basically, those are things that look like functions but are run in your application as it's being debugged, but the debugger provides that. So for example, you can get the length of a string or an array or the ref count, things like this. So you can access values without, and yeah. Extended operators is actually, that should be singular. There is one extended operator so far. It's a very similar thing, and I'll show that in the course of the thing. So basically, it's like when you write a plus b in a watch window, there's an operator for an array slice that has some extra functionality. We have something that's called converters. Now, this basically currently is mostly for variants. Variants are normally shown, so if you have a value of type variant, then it's normally shown as a record, which means you do see fields that you don't necessarily want to see, because you're really not interested in the vKind field. If it contains a string, you want to see the string. If it contains a number, you want to see the number and not all the rest. Because, well, you might want to see all the rest, but you can decide what you want to see. So the operator here basically, the converter basically, when you've configured it, will detect this value is a variant, and it will then display the values that your application sees. So the string, the number, whatever is currently stored in that variant. There are two of them. There's something called custom variants, where you can store your own kind of data. And there is a function in the RTL which can print that into a string if you properly registered your custom variant. And then, so there is one that does the work on known types without calling your application, and there is one that does it on all variants but needs to call your application. I have an example of that, so I'll show that later. If you do low-level debugging, you now can access CPU registers in the watches window. That's important if you have an address in a CPU register and you want to use that as a pointer and see the memory that it points to.
Thanks, Matthew.
I was mentioning the thread window before. So now, when you are paused and you have a threaded application, you can actually suspend individual threads from running. That only applies to pure FPDebug. So if you use FPDebug plus LLDB on Mac, some of all the features are available, but not all of them, because on Mac you have LLDB in the mix, and not everything is either implemented to be done through LLDB, or in some cases, LLDB might simply not allow us to do it. Shared library debugging is also working. It has a couple of issues when it comes to displaying which lines have code. So basically, normally you get those blue dots where you've got compiled code. That doesn't quite work, but you can set breakpoints there. You can catch exceptions in your libraries. All that does work. Again, for people who do low level, we've done some work on the disassembler, something that I also plan to show, so I'm not going into details for that right now. The whole mem limit thing on the pure FPDebug, that already existed. It already existed on the GDB debugger. It's now also available for Macintosh. Basically, if you have a dash variable, if you have an invalid pointer and that points to an object that might contain a dynamic array or string, something that has a length, and then if it's not pointing to proper data, it might be very long. It might be a 10 megabyte string, which you might not really want to load into the debugger because it costs a lot of time. And so basically, in the debugger configuration, there are some presets that already limit that. So the debugger says, if that value is bigger than this amount of memory, then I'm not going to load it by default. Okay. So we've done a lot of front-end work this time. We've got a lot of new ways to display values in the watches window. Again, something that I'm going to show in details in the IDE. Things that you've probably seen in other IDEs and that were long overdue. We have same thing for the local windows. The inspect and evaluate windows have been redone, and I will show all of them, so it doesn't make sense for me to talk against for all of that at the moment. And as mentioned, also the disassembler window again that's going to be shown. And then we have a few changes to the options. In the past, you do your debugger settings globally in the IDE global options. And if you had a project that, for example, needed a remote debugger, you had to open that project. You then went to Tools, Options, went into your global options, changed the debugger backend there. And if you went back to another project, you had to change your global options again, which is not really convenient. So now in the options for the project, I'm just bringing that up if I can find it. Control Shift. For some reason, project options. Now, under debugger, you have complete duplication of the configurations for debugger backends that you would have in the IDE. You have the options to just say, I want to use one of the global debuggers, but not the one that's set as default. Or you have the options and you can add a new backend. For example, if you have a remote debugger and it needs to connect to a specific IP address that's specific to that project, then you don't really have a point to put all that configuration in your global options. You do it in the project, and you don't have a trouble anymore to change it each time you change projects. So that's it. And I'm also through the feature list on the slides, at least for now. I'm now going to go to the demonstration in the IDE. Any questions up to here? Any requests, anything you are particularly interested in the debugger? Good.
Anything from the debugger?
You know, I'm just, glad to have some feedback. So, in that case, let's close that. Wait for one example. No, I don't need that. I just need my help. All right. So the first thing we're going to look at are the intrinsic functions. This may not be the ones with the biggest wow effect, but I'm saving the good ones for the end. So I've made a small application here. It's not big enough, too small. It unfortunately doesn't fit onto one screen. Yeah.
Could you
speed up?
No, it's because of the time. It's 10 minutes to 5.
Oh, okay, fine. So then I don't explain the application. I just set the breakpoint and show the feature. Sorry, the clock's behind my back. That's not helpful. I don't know who placed it there. Where's the line number? Line 47. Done that. So then basically I have an input as that. Right, I have a thing here that watches window. So basically an input. I've got a string here. As I said, we have intrinsic functions. So if I wanted to know the length of it, then I would do, I hope that's big enough to be read. So intrinsic functions usually start with a colon. There is an option to change that to an exclamation mark for those who don't like the colon. And I've now put in colon length an input, which is a string. And I look at this and I get this string has 262 bytes of length. Or chars of length. We've got various other ones. You can do a substring, so you can look at a part of a string. You can upper or lowercase strings, which might be interesting if you have a condition for a breakpoint and you want to stop when it's hello, but you don't really care whether it's upper or lowercase. We've got rounding and truncating for floats. Yeah, I'd have to look at the website otherwise, but those kind of things. So things that you could use if you have a condition to stop on a breakpoint, and then that would work. Then, well, I can do the debugger, the assembler just on this one. Then, just to be quick, view debug window. It's the schedule obviously has changed several times in which order the talks would be and how long each talk would have to be. So basically what's new here, that's the disassembler window. If you for some reason had to go low level. And the new thing now is that, for example, here we've got a conditional jump and it tells us to where that jumps. And even more, if I press control, it becomes something. And you also see 2 lines later, there is that arrow and it changes color. So if I'm pressing the control key and I'm hovering over it, and I see where that would take me. You know, I can also control click it and then see that code. So if that was a call to some other memory that wasn't there, and I didn't want to step in, but I wanted to see the assembler of the other routine, then like I can follow Pascal code in the editor, I can do that in the disassembler window. Questions? Good. Good insofar as that the clock's ticking. Let me just open the array example. No, not needed to change. That is array is line 88. Right. Yes. Well, about now, this is one of the bigger changes, or I call it a little bit. Now, this is an array that I've now put a watch on, and this is how it would have looked earlier. So you've got one line, and that says, you know, you've got those entries, and then eventually you're running out of display space, and you don't actually see the data anymore. The thing that's new is the plus sign. And that's something you know from every other debugger in every other IDE. So it was time we get it as well. And we got one step further than, for example, and that's the one earlier this morning we said we have one thing where we might be better than Delphi. Because when you have an array with 500 entries and you expand that in Delphi, your watch window is filled with all 500 entries, and if you have another watch below and you want to see that, then happy scrolling. We've got pagination for your array. So basically, in this case, it's set to pages of 10, but you can edit that here. I can put in more here. Sorry, should be able to put in more here, yeah. And then I've got more entries. If I keep that at less, then I can go to other pages. And so I can do all that. And obviously it's nested, so I've got an object in here with count and another array. So I can see, I can expand this and I can keep doing that. Get another one like this. No, closing this one again. Now, if I were, for example, particularly interested in this value, so I want to keep stepping in my debugger and I want this value in view, I can leave that open, but then I have all the other lines here. I can just hold it and drag it here and have this value here as a new watch. I can do that with an array element. I can do that with a field from an object. Either way, I just have a new entry here. I can also use that to reorder my watches. Let's say I've got 3 counters that I normally, you know, that are somehow related. So I want them close to each other in my watch window. But I forgot to add one. I added more watches, and now the last one is on the bottom of the list. Then I just pick it up. And that's also something we didn't have before. And before that, you'd either had to live with it being somewhere where you wouldn't find it, or you had to re-add all your watches. Any questions? Yeah?
Can you print it?
The watch window?
Yeah.
No, not yet. It's a good idea. It's not even on the idea list yet.
Yeah.
So, no, you can't. I mean, you can go and copy the value of a watch, and then you can pass that somewhere and print it. But the watch window itself doesn't have a print function at the moment. So, printing is something in general that is there isn't also a good function to print your sources. So that's a topic on its own and way beyond the scope of this presentation. So those are those two. So this basically are some of the, or one of the big wow changes. Yeah, I can go here and copy the value of what it's one value. I think. Let me see. I should be able to just copy value here. All of them. Sure. Let me just go to the bottom of this. And how do I? So okay, this is a bit. Let me just get another count up here. Select the to count. It might be that it's one value only at the moment, but I'm happy to have that as a suggestion, as a feature request on the bug tracker. It's certainly a feature that we should have. Why don't I? No, it's only one value at a time at the moment. I just tried. So even if you select several ones, the one that has focus in the selection is the one that you copy. It's something that could be easily added, and I fully agree it's something that ought to be added. So yeah, best thing is to add it to the bug tracker feature request, so I have a reminder of it. I'll try to not forget it, but depending on how many other feedback I get today, you know, so that's that part string list. Okay, so then let me just go back to stop this project. No, and now this is actually one of the ones. Now we all know, or probably most of us know, that one of the most demanded features is the properties. It's be able to inspect properties if they have a getter, which unfortunately is still. We are one step closer. We are not yet that close, because basically, in short, it requires first changes to the compiler and then also to the debugger, which means the earliest it can happen is FBC 3.4. So that's going to be a bit, unfortunately. But one of the points where that is often needed is string list. You want to see all the content of your string list, and you don't usually get there. So I'm going to go to the inspect window now. Debug windows. It's okay, fine. I just need to go to my list. Debug, inspect. There it is. So this is the reworked inspect window, and it shows the string list. And I mean, I can go on the list. I can go there. I can look at a single item, the item with the number 0 in this case, and it shows me the string and the object. I'm interested in the string, so I'm going there. Now I'm seeing one string and one string only. But what I can do is, and that's the special operator, I can get a slice of this array. Yeah? So I'm saying from 0 to 99. There might not be 99 entries, but then up to 99 or wherever the array ends. And if I do that, I'm seeing all the entries from the string list. And I'm only seeing the strings. I'm not seeing the objects, because there are two things happening here. I'm having the slice of the array, but I'm then, the slice of the array would actually be for each entry the object and the string. And I'm then operating on each of those, on each array entry, and getting the f string field. So this is a little bit like you would have map in JavaScript, where you feed it with a list, and you then in the map you say, get me that field of each entry. And if you have an array returned by this operator, then you can operate on the array as if it would be an entry of the array, and it will be applied to each individual entry. And I'm probably going to put an article about that on the wiki at some time soon. So let me explain. But basically, this is the way you can now get to your string list and to all the strings in it. And then also, since we are just in the debug object, in the vector, so the other thing that's, there are a lot of fields here. One other thing that's new here is you have a filter field. So if I was looking for the count in that string list, I start typing here and I get the count, and it filters the entries, and I can press, I think it's control return, and it selects that entry. So if I had several entries, so there are several, and if I wanted the update count, I can navigate, and then I can use control return to go to that entry. Now, if I have a set of nested structures, yeah, and an object with hundreds of fields, I can get very quickly to any entry in that nested structure. I'm just starting on the top one. I know the field contains foo or it contains bar. I start typing that into the filter, navigate the remaining list of items, press control return to select it, maybe get a new list or get an array where I then can go to an entry by number, or the filter also acts on the values that are returned. So if I want to know there is something that has a certain word in its value, then I can type in that word, and if any value contains it, it'll be returned by the filter. So that can help me quite quickly to find either a field or to see if specific data is somewhere within the values that I'm looking at. It's currently only available in the debug inspector. It's something that I hope to add to the watches window as well, because we've got similar conditions there. We've got lots of watches. We might just want to see, you know, do we have that value in our list already, or I want to quickly filter it down to just compare a few watches, something like this that I can do. Next example. So I was talking about converters before. That's basically here. Now, basically what that is, it creates a list of variants like you might do if you do a basic translation cipher. You know, so you have a number and a letter in that array. Just let me add it to the watches. There it is. So here you have the list, and as you can see, it's a list of variants. So you see V type, which is 3, and then V integer, which is 1, and then you see V type is 256. This isn't very readable in the end. So what I can do is I can go to the properties. I've configured that earlier. I can show you the configuration in a moment. I can also automate that it will do that, but I haven't. And I choose a converter. In this case, I called it variant. If I do that, then I just have the values. Nice and readable. And basically, I've configured it down here. You can also do that configuration on a project level. And there is the thing, and it only works if the type is called variant. And I unchecked it, so it doesn't work by default. If I check it, then it will be on by default, and I have to disable it if I want to see the full record type with V type and V integer and everything. So that's the converters that we had earlier on. And at the moment, we've got mainly the variant ones. We have a converter where you can call a function in your code that's called JSON for debug, that can return any JSON value for the value you're trying to watch, and then the watches window will display that JSON, and it can unfold to JSON, so you can expand it and look at it. So if you have some crazy structure in your code, and for the debugger you want to have a completely different representation, then you can write your own code in your application that returns a JSON representing what you want the debugger to show. And we might get other converters in future. That depends on what ideas come here. Obviously, I'm now going into the idea range for the future. We want to also have features like this without needing to call the debugger. So that basically, when you get a point or you get a rectangle, yeah, then you might want to display it in a different order. So you might want to have some snippet of Pascal script or some plugin in the IDE that says how to format a record as text in the watches window. It's one of the ideas for the future. So this was really cut short now due to the clock. If anyone has any question to the presentation part, otherwise I'm moving forward to the ideas part for future features that hopefully will be added. It's late in the day, I do understand that. So, okay, we've done that. So yeah, basically, I've mentioned already properties. I've explained we need to coordinate that with FVC in order to get it working. Then display formats. At the moment, we have a list of display formats, and then also when you have a stack trace, sometimes the values are very verbose in the stack trace. So the very different values are displayed in different contexts. Obviously need to be enhanced. I'll probably at some time start a discussion on the forum and I get some feedback, what everybody thinks, how those values should show, how should a string be shown, how should a PR be shown when it's in the stack trace, when it's in the watches, when it's in the locals windows. You know, what should be the default, what format should the user be able to choose from quickly as hard-coded formats, you know. And then, as I said, programmable formatters, so either third-party plugins that you install as a package into your IDE and that can then change the way the IDE displays your value, or the ability to just have some Pascal script that gets the value that will be displayed in a structured form, so not yet as text, but as a raw value, and that can then decide how to return it as a string that can be shown. Then on the step-in blacklist, that's one of the things that comes up rather often. If you have an LCL that has debug info and you use F7, step in, then you end up somewhere in LCL code. You may want that, you may not want that. If you have an RTL with debug code and you want to step into your function, but it's a method, it's a virtual method, then you might first step into the FVC code that checks that you are actually on an object of the correct type. And in 99% of all cases, you don't want to step in there. At least I never want. So basically, one idea is to have a blacklist where you can either specify functions by name or units by name or functions by unit and function name. And then when the debugger sees that you would step into one of the blacklisted functions, it says, I'm stepping over that because the user didn't want me to. Similarly, okay, that's something I forgot on the demonstration now. As I said, the thread window now has the ability to suspend individual threads of your application, meaning you can continue a single thread, but you always have to go to the thread window, have to change the status of the thread. It's quite a lot of work. So that needs to be simplified. That needs to be made easier in the thread window itself, and although there could be a step, an actual hotkey that says the next step is only for the current thread, and all other threads should be suspended just for the one step. Depends on what you do if you have a threaded application. Breakpoints as well certainly need that. If you have many threads, then you have a breakpoint on code that's run by all threads. You might only want to catch a specific thread. The other one would be like, you might want to step through something recursive, but you only want to reach the breakpoint when you come back from the recursion. So it shouldn't react while you're further up in the step point. One of the more often asked for items is a memory viewer window. So that doesn't need much explanation, I believe. The console windows on Linux, that's one of the sore points we have. So that needs to be improved too. And also, there are ideas how we might in the future be able to get back to actually debug within a proper terminal. That used to be possible about 10-15 years ago. Then something changed within the Linux terminals themselves, the way they work, and ever since it hasn't. An FP debug server, similar like a GDB server, either for remote debugging or even within on the same platform, there are use cases for that. And since we have control over the application, there's even the option of eventually making FP debugging into a simple profiler. That's one of the ideas for the bit further away future. Nothing that will happen right tomorrow, but it could be. And obviously, there was mentioned better copy and paste copy from the watches window, which isn't on the list yet, but belongs there. Sorry, what's yours? Okay. Yeah. Oh.
This is white. This needs not better than a black list. Only say, look at this case or other.
If you would say only stay in the project or only stay in the project and this packets, then maybe, but then it might be easier to, where you normally, when you want a whitelist, basically means you say step in. You use F7 instead of step over. So you already have that control to some point. But if step in brings you into a function, but I mean, yes, that's discussable. But for many of the cases I know, it's that you actually decide to step in. So the target you're looking at is that you step in, but there are hidden functions before, and you want to avoid them. So that's that. Or you don't want to step into the LCL as well. But what I could see is that when we have a blacklist, that you whitelist certain items. So basically, if you say on the blacklist, you blacklist an entire package, then you could whitelist certain of the entries. So you could have a whitelist then for that. That would be a possibility. Yeah, but it would kind of first need a blacklist, and yes, you could just have an exception from the blacklist kind of thingy then. So yeah, that would work.